Welcome, and I have a visitor today to assist me in the kitchen. I've got to get this little box off our screen. And this is Zach, my son. You've heard me talk about him, and some of you have seen him when he delivers coffee to me. What we're going to do is we're going to talk about examples and show you examples of rates and ratios. Zach's going to help me with the rate today. Remember, a ratio is when you just have a comparison of two different things and how they relate to each other. It doesn't work. There's no work going on. And the units are always the same unless you're doing a mixture, which we're going to do in a little while, you'll see. And then that's how it blends. So a ratio is important, how we keep the eggs and the flour together, and that we keep it proportionally the same. So if I double the mixture, it will have the same taste and same consistency. Even though eggs and flour are different, it's still a ratio. A rate, though, works. And a rate is always different units, and the units have to be in the final answer of the fraction. But remember, the fraction, you don't say it as 2/3. You say, if it's a rate, 2 per 3, 2 miles per 3 gallons. Now remember, that's not a unit rate, that would just be a rate. But what we're going to do, and Zach's going to assist me here, is we've got this, it's longer, it's bigger than a yardstick. It's 48 inches, and I'm going to put it at the top on my counter here. And I'm going to drop this egg from the top of this yardstick, well, it's bigger than a yardstick, of 48 inches, and Zach's going to time it. And we're going to try to get how fast does an egg drop from 48 inches before it goes splat. And Mr. Al here is helping us here in the kitchen today. He's back. Remember, he's back down. He didn't make it to Cranbrook. He came back. He likes my kitchen better. He tried to get there, but he didn't make it.
He doesn't fly.
So, he doesn't fly very far. So I'm going to drop this egg. Zach's going to time it. The rate is going to be inches per second. So write that down. Remember, you need a piece of paper. So I have to stand up too old, although I have a new knee, so I can do this. All right. So when I say go, when Zach tells me to go, well, I'm just going to drop it, and then he's going to time it. Okay. Gross.
All right. So everyone, it took 0.63 seconds, which is 63 hundredths of a second, to drop 48 inches. Now, why don't you try to find out how far the egg would fall if this wasn't here in a single second. So work on that right now.
So set it up, inches per second. But first you're going to say inches over seconds. It was 48 inches, and it fell in 0.63 seconds. So pause the video and see if you can figure out how far it will fall in 1 second. Welcome back! Zach's going to take over and tell you the answer you should have gotten and explain to you why it might look a little odd. Zach?
So basically, the answer that you should have gotten is about 76 inches per second. Now, how did you set that up? Well, you put the inches, it was 48 inches that the egg fell from. Fell a complete 48 inches in 0.63 seconds. So, since it took 0.63 seconds to land, and you're looking for inches per second, you're going to put the 0.63 seconds on the bottom, or in the denominator of that fraction. Then, when you divide 48 by 0.63, you come out with 76.19 inches per second. Now that sounds a little strange, but it didn't take a full second for that egg to fall onto the countertop. So for a whole second to elapse, we would have to have 76.19 inches for it to actually fall and hit the countertop in exactly 1 second.
And that is an example of a rate changed to a unit rate. I'll be back in a second with a ratio. Zach, thank you very much for helping me.
High five.
See you soon.
Look for the elbows.